Hey, Chris.
Great, thank you. Can you see my screen?
Yes, I can.
Great. All right. My name is Chris Landsea. I'm the branch chief for 18 marine forecasters here at the National Hurricane Center. And to kind of lay it out to you, we're going to talk about our mission, our products, and our services that we provide for blue water mariners, basically anyone traversing the open ocean. And focus today is on the Pacific Ocean. So I'm going to talk about the tropical Northeast Pacific. And to put our responsibilities into context of where we're at in the federal government, TAFB is our marine branch, Tropical Analysis Forecast branch. National Hurricane Center is where we're at here in Miami. That is part of the National Centers for Environmental Prediction. NCEP is part of your National Weather Service. National Weather Service is part of NOAA, National Oceanic and Atmospheric Administration, and that's part of the Department of Commerce. So all of this means we're all federal employees. So thank you when you pay your federal income tax. You help keep us afloat. So first slide. What we do for marine forecasters is not just under the auspices of the National Weather Service, but also through the International Maritime Organization. So the IMO is actually part of the United Nations, and it's in existing to help keep mariners safe over the open ocean. And each of these little polygons represents a big chunk of the ocean and which country is responsible for it. So for example, if you're in the South Indian Ocean, then Australia is responsible for providing free marine forecasts of winds and waves and issuing warnings for that part of the Indian Ocean. So the United States has a good chunk of the North Pacific as well as the North Atlantic. Drilling down a little closer to home then, for the Pacific Ocean, which is the focus of today, TAFB, the branch that we work at here at the National Hurricane Center, has the light and dark green areas. So basically it's 5 million square nautical miles going from about the equator up to just south of San Diego and out west to 140. West of our waters is the responsibility of the Honolulu Forecast Office for those fortunate to live in Honolulu. And the Ocean Prediction Center, you're going to hear from later, headed by Darin Figurskey. And so that kind of breaks down the areas of responsibility. The dark green basically is where we have more products and services available for the mariners, because that goes along the shipping route. Speaking of which, when I took over this position 3 years ago, I was really shocked how many hundreds of giant vessels there are traversing the open ocean every single day. And as you can see, going from Southern California, past Baja California, Mexico, all the way down to Central America, and especially with the larger Panama Canal allowing more access by giant cargo ships, there is hundreds of ships going along this shipping route every day, as well as ships that go out to Hawaii as well. And so this would be oil tankers, this would be cargo ships, it would be fishing boats, it would be giant personal yachts, it'd be cruise ships, it would be the US Coast Guard. So anyone over the open ocean that we can see when using the marinetraffic.com site, hopefully they're accessing our forecasts and when needed, adjusting their ship route so to stay safe. So this time of year, we switch from hurricane season to the extratropical season or winter season. And so the areas that are hatched out, I'm going to focus on in the Pacific, where we can have gale force wind events. And so we get gale events just off of Baja California, as well as in the Gulf of California, due to strong fronts, as well as extratropical cyclones that are traversing the area. Farther south, though, the Gulf of Tehuantepec is a unique area. When we get a strong cold front barreling across the Gulf of Mexico, it'll set up a gap wind event as the winds squirt through the gap in the Sierra Madre Mountains. That's called the Chavela Pass, and you get a strong downslope wind event. So it's very, very common to have gales, occasionally storm, and we've even had a couple of hurricane force wind events, completely clear skies, but mountainous seas due to this gap wind event. There's a similar but less violent gap wind event near the Gulf of Papagayo. And occasionally we'll have gap wind events off of southwest Mexico, as well as the southern Gulf of California and just west of Baja California. So these are forced by the topography, or the mountainous terrain. And so that's why we get those gale events and very frequently during the wintertime. So some of the tools that we have, and when we're making wind and wave forecasts and issuing warnings, you have to measure what's going on. And one of the key tools first is ship observations. And so of all those hundreds of ships, we only get reports from about 5%. And so we would encourage mariners over the open ocean to sign up for the VOS program, the Voluntary Observing from Ship Network, which is a global consortium where you can provide measurements of what you are observing with temperature and dew point and wind and wave heights, because that helps us out as forecasters, as well as helps the computer models for making better predictions. We also fortunately have some measurements from satellite. These wind barbs that show up as a swath are from a scatterometer that the European Space Agency maintains for us. And so we can get a big chunk of the ocean with winds. The colored numbers are actually altimeters. So it's another radar in space, but in this case, it gives you wave heights and it's accurate to the nearest foot. So it's incredible. One thing we're lacking is in our entire 5 million square nautical miles, we don't have any wave buoys that help inform us of what's going on. So we use a mix of these kind of in situ measurements from ships, as well as remote sensed from satellites. Another key tool is the satellite imagery themselves. A couple years ago, NASA launched and NOAA operates the next generation of geostationary satellites. And so the one that you're seeing for the video here is GOES-17 imagery. And so this gives us a pseudo true color for the first time of what's going on, unprecedented spatial resolution, and is as often as once every minute. So incredible opportunity for us to view what's going on over the open ocean, which is important for us because a lot of what's occurring is coming from the open ocean where we don't have a lot of measurements. But if we can visually see it, then we can identify what's going on. Another key tool are the models, the computer models that help provide us forecasts of winds and waves. We generally take a mix of the deterministic global models. We can't use what's called the mesoscale models or local models because it doesn't cover our whole area of responsibility. And so we would typically take a mix of both the global forecast system that the National Weather Service runs, as well as the European Center for Medium Range Weather Forecasting that provides global forecasting of winds for us as well. We can also use the ensembles of those, which is a collection of lower resolution models. We'll then blend that with available observations of what's going on right now that the model may not know about yet. And then we have a collection of wind grids that go out to 6 days. We run a wave model, and it's the only model we run locally. And so it's the nearshore wave prediction system, and it allows us to have consistent wind waves and swell that match our wind grids. And so that's fairly unique. There's no other center outside of the National Weather Service that is providing that continuity of service between the winds and consistent waves. The other access for tools is through our workstations. And so we're moving toward using a unified system called the Advanced Weather Interactive Processing System, or AWIPS, so that we can have everything on our workstations. We don't want our forecasters going to 20 different websites because we can't get the job done in time. But AWIPS allow us to look at the satellite imagery, get the scatterometer, the altimeter observations, as well as the ship observations, and the computer models, and put everything into a gridded database called the National Digital Forecast Database. And that allows us to provide all our products. So that's really critical for us as forecasters to have everything in one place in order to get our products and services out. So one critical question is, how do you get weather forecasts over the open ocean? If you're on shore or you're close, then certainly the best way is through internet access. But as many mariners know, internet access is still difficult to get or very expensive to get over the open ocean. So within 25 miles from shore, you have NOAA weather radio that's available. Further out, you have the voice broadcasts that are high frequency, as well as the radio fax providing graphics. And I'll show some examples of what those are. In the past, the IMO has mandated that Inmarsat provide through the Global Marine Distress and Safety System our text products, our high seas, as well as what the hurricane specialists provide when there's a tropical storm or hurricane. Recently, Iridium has gotten into the game as well, and so they are starting to provide access to the products as well. We're trying to get that into operations so we can work with Iridium as well. Another way to get access is through FTP mail. So you can get one product by an email request. So even if you have very low bandwidth, like many sailboats do, one can access products, both text and graphics, by email. And then lastly, we've developed a marine composite page. So even if you have just a small amount of internet available on board, you can access our grids and see what's going on visually. And I'll give examples of that as well. So how you get the weather forecast really depends on the technology you have on your ship and where you're at. So some of the products, one of the key ones is a unified surface analysis. And this is where we put together a weather map comprising the entire Western hemisphere north of the equator, and it goes every 6 hours. And so the folks in Honolulu provide the Central Pacific. Ocean Prediction Center has the high latitudes of the Pacific and the Atlantic, and the Weather Prediction Center does Canada and United States. Whereas in the TAP B, we do the tropical portions of the Atlantic and the Pacific. So let me just show you, what's the map today? And this was done by our newest forecaster, Dylan Flynn. And we can zoom in a little bit on the Pacific and see what's going on. There's a pretty vigorous cold front going up across California. And that has entered our area of responsibility, but it's not a gale. We would indicate gale on the surface map if it was. Fairly weak ITCZ, Intertropical Convergence Zone, and monsoon trough getting into Central America. So not a lot of features in the Pacific right now. That's not often the case, as wintertime is a peak season for our warnings. So we do have one discussion that we issue 4 times a day, every 6 hours. We have one for the Atlantic and one for the Pacific. And so the focus is on big events. And so right at the top, we would have any special features. So if we had any gale or storm or hurricane wind warnings, we would focus on that. We also break it down by geographic area. So I'll just show you briefly the one that was issued just a few minutes ago. And this is by Gladys Rubio, one of our marine forecasters. And so we talk about offshore waters within 250 miles of the Mexican coast. Then we have a section that talks about the offshore waters for Central America and the equatorial waters out to the Galapagos. And then the remainder of our area that goes out to 30 north to the north and 140 west to the west. And so usually talks about what's going on now in the first paragraph and what the forecast is over the next 5 days. So you get a reasoning why about what is going on with the forecast to accompany what the predictions actually are. So as I mentioned, we use a gridded database of winds and waves and warnings so that we can communicate what's going on to the mariners. And we do that. We provide the grids. They are directly accessible. We also have graphics that fall right out of our grids. So once we have the winds and the waves the way we want them in the forecast, our graphics come out of that directly. And same thing with our offshore zone text as well as our high seas. We have text formatters that provide the forecast information. So that allows our forecasters to really focus on the meteorology and the oceanography and make the best forecast possible for the mariners. So the high seas, I mentioned earlier, that's part of the Global Marine Distress and Safety System, and it goes out through 48 hours. It's issued 4 times a day, and I'll just briefly show that. So this is the one that was issued by Gladys just a few minutes ago. We have no warnings in place right now, and we do focus on anything with at least 8-foot seas, so that's about 2.5 meters high, as well as 23 knots or greater. And that's within a 48-hour time frame. So this is a fairly coarse, broad brush product. To get more information, we have our offshore zone product. And so this was started, it's fairly recent, it's 2 years old, and you can see the polygons extend within 250 miles of the coast, and it covers the main ship lanes that go from Southern California down to the Panama Canal. We'll take a quick look at that. We do have a nice GUI that allows one to interrogate the forecast very quickly. So if we want to look, for example, that Gulf of Tehuantepec, this was the forecast that Gladys issued, and it's in 12-hour increments, and it goes out through 5 days. And you can see we have a section on the winds, the waves, as well as the periodicity and the swell direction as well. So those are the text products. Everything else is graphical products, because we understand that graphics really is a much more efficient way to provide information about a forecast. And we're very much indebted to the US Coast Guard because they maintain our radio fax transmitters, one in California and one in Hawaii, that allow those vessels, especially cargo ships that do not have internet access on board, to use the high frequency receivers. So one of the products we do is the surface progs. We do day 1, day 2, day 3, and we issue these twice a day. And these are both available on our website as well as radio fax. I do want to briefly show, this was what was done just a few minutes ago by Gladys. And forecast, again, keeps it pretty quiet for the next 3 days. You can see the isobars, and there's a high of 1026 just north of the area. But no gales expected over the next 3 days. Fairly tranquil Pacific going forward. We also provide an analysis of what the sea state is. And so this is the main wave direction, where it's coming from, as well as the wave heights in feet. This is issued twice a day, focused on 0 Greenwich Mean Time, or UTC, as well as 12Z. Another product that's provided through the radio fax is the wind wave forecast graphics. Again, it's days 1, days 2, and day 3, issued twice a day. And it shows the 10-meter winds as well as the wave heights in feet. And so we can take a look at what Gladys had provided. Again, fairly tranquil 3 days from now, showing for the Pacific, fairly low wave heights, only 8 to 10 feet, or a large chunk of the ocean, and no gale force winds anticipated for the next 3 days. And then finally, we have the wave periodicity and direction. And so this shows the radio fax version is black and white. Our internet version shows colors, where wind waves having the very short period, say of 8 to 10 seconds, show up in blue, and the long period swell that could be 15 or 20 seconds shows up as red or brick. And then the last radio fax graphic is the high wind and seas graphic. This is issued 4 times a day during the winter and spring, and it's a snapshot of any warnings we have in place right at 48 hours. And so we don't have any gales anticipated for the next 48 hours from now. So I mentioned earlier the marine composite page. So for those that want to move beyond just radio fax, we do have a way to display our grids of our winds and our waves, as well as the hazards. And so we do that on our website using very low bandwidth GIF images. So this is an example on the right side of the winds and waves for a very strong Gulf of Tehuantepec event, or we call them Tehuantepeckers, that occurred a couple years ago. And you can see in the wind heights, the wind barbs showing there. And in color, it has the wave heights, and where it reaches the red, that's about a 20-foot wave. And on the left side is essentially a graphical depiction of what we have in our high seas text forecast. To me, it's a very efficient way to see what's going on, where the blue indicates at least 8-foot seas. The orange indicates at least 23 knots of wind. The stippling indicates both. When you get red, then that's where you have a gale event. And in this case, you even reached storm event, or 50-knot winds. So let's take a look at what's going on right now over our marine composite page. So if we go to the Pacific version of it, so click here and then here, And so it's a menu-based GUI that you can access. So we'll select 10-meter winds, for example, and we'll look at the wave heights and then our features. So this is the forecaster drawn forecast features of what's going on. So this was from 12Z this morning, showing again that cold front, and behind it, even though the winds aren't very strong, we've got some very significant swell, 15 to 20 foot swell out of the north. So we can toggle forward in 12-hour increments. So you can see the progression of that cold front as it moves south and eastward. And then by 48 hours and then 72 hours, that swell moves across the Pacific and then weakens as it's slowly subsiding. We can also show if there's any hazards. So in this case, do we have any GALE events? And we do not have any GALEs showing up at this time. Actually does suggest we could have a brief GALE in 24 hours there. So, we also have the opportunity to show what is the peak wave height in the next 5 days, as well as winds. And so this shows the peak winds over the next 5 days. So if you had any purple, it would show indicate any gale force wind events. So again, it's to me, it's a very useful tool. One other last thing I did want to show is that we can also now provide winds beyond 10 meters. So this shows, for example, 10-meter winds. This shows 30-meter winds, and this shows 50-meter winds. Not a dramatic difference for this particular forecast scenario, but we realize that ships are very much higher profile and wanting to get wind conditions at 30, even 50 meters above the ocean. So finishing up, those are the main products that we provide for mariners over the open ocean. Again, it's a mix of gridded and graphical and text products. I did want to point out our services. We serve one key governmental organization, and that is the U.S. Coast Guard. And so in the Pacific Ocean, we work with District 11, which is in Alameda, California, as well as District 14, which is in Hawaii. And these targets indicate where we provided spot forecasts in support of their operations. So it could be a ship in distress, it could be a missing ship, it could be an aircraft that has crashed, it could be an oil spill, it could be law enforcement activities where they're not telling us what they're doing, but they need a forecast in support of because the winds and waves affect the Coast Guard every single day. And so that's an important service that we provide, since the U.S. Coast Guard does not have any forecasters on staff. So by renewed agreement, the National Weather Service provides that level of service for the U.S. Coast Guard. I did want to also highlight our increasing media, social media presence. We provide at least one tweet a day, and when we have a warning, we focus on that event that's going on. We also are including more climatological information when it's a quiet day. And so it's another way to help inform the mariners on what's going on over the open ocean. So that's a bit of a briefing from the Tropical Analysis and Forecast branch of our 18 marine forecasters. We work 24 hours a day, 365 days a year, and carrying out our mission to keep mariners safe and to help safeguard your cargo, whether your cargo is oil or bananas or people. You want to make sure that that you get across the open ocean safely. I did want to point out that we have a direct number. So if there's a mariner over the open Pacific that has a question, you can reach us directly. We are staffed 24 hours a day. So I think I'll stop there. And again, at the top is our website if anyone has any questions. Thank you very much.
Well, thank you very much, Chris. Right now, I don't see any questions in our question box. So why don't we give people about a minute in case they're still typing any questions for you before we hand it over to Darin. So again, for those on the line, if you see the questions box, if you have any questions, you can type your question in the questions box. All right, well, if you think of a question later, you could always put it in the box, and if we have time, we'll get to it at the end. And if not, we will we'll get back in touch with you. Oh, I see one question. Hold on, Chris. Someone is asking, do you get wind acceleration across Baja California from the west?
Yeah, that's a good question. So when you look at the topography of what's going on, I'll bring that slide back up. Occasionally when we have a real strong front, there are gaps in those mountains in Baja California. And those winds, if they're a west wind, sometimes they will squirt through those gaps and get into the northern Gulf of California. Same thing if we have a strong northeast wind, the reverse may occur, where we could get a gap wind event that occurs in the Pacific Ocean as those winds are funneling through there. And occasionally those can get up to gale force. And so we would indicate that in our grids and our text and our graphical products.
Thank you, Chris. All right, well, at this time, I don't see any other questions. So, oh, actually, yes. Yeah, that's it. All right, so we'll go ahead and get started with Darin's talk. Let me see here. Darin, I need to make Darin the presenter. All righty, Darin, you should be good to go. Oh, oh, wait, I need to unmute you. There you go. Oh, sorry about that.
All right, we worked that one out. Andrew, thank you very much. And it's my pleasure to be here with all of you today. And I am Darin Figurskey. I'm the Operations Branch Chief at the National Weather Service's Ocean Prediction Center, Chris's counterpart to the north. Wherever you are today, I hope things are going well for you. Thanks for being here. So I want to talk just a little bit. Chris described it briefly about how we are housed within the federal government through the Department of Commerce and NOAA. The Ocean Prediction Center and the National Hurricane Center are two centers among the 9 centers of the National Centers for Environmental Prediction in the Weather Service. There are several of those. You see them listed on the screen: the Aviation Weather Center, Space Weather Prediction Center, Storm Prediction Center, other centers that help us with climate prediction, do our models, help keep things running like our central operations, and work on national things over land such as rainfall forecasting and help with snowfall prediction like the Weather Prediction Center does, as well as doing some analyses with us. But the Ocean Prediction Center, we're located in College Park, Maryland. The Hurricane Center, of course, in Miami, Florida. And the forecast area, Chris showed some of that already. The blue is the area that the Ocean Prediction Center covers. The purple on this map over the Pacific is done by the Honolulu office. Chris's office there at the Hurricane Center. The Tropical Analysis and Forecast Branch does the area in the green. And then there are high seas products. We do at the Ocean Prediction Center, the area in the kind of the closer hatched areas by the US West Coast. Those are offshore zones. The high seas are to the west of that. And we have an area that bounds the Alaska forecast offices to our north. In the Atlantic, just for awareness, for those that may go out over that way, the same kind of thing. The Ocean Prediction Center's high seas and offshore areas are in the blue, and Chris's office there at the Hurricane Center's TAF B does the area in the green, with the offshore zones in darker green, highlighted by the high seas forecast area that overlaps that in the lighter green. Chris had mentioned the WMO med areas, and areas around the world have their different places that they are supposed to be the authoritative voice for, particularly when it comes to hazards like warnings. In the United States, we are part of med areas 4 and 12 in the circle here, and other nations around the world have their own med areas that they cover, again, to be the authoritative voice for warnings for the safety of life at sea. And why do we do what we do? Well, these two maps here really kind of show it. And these are heat maps of extratropical hurricane force lows over the North Atlantic and the North Pacific. This is just from 2020. And the average in both, in the case of the Atlantic, is 45 each season. In the Pacific, it's 36. I think in 2020, we were just a little under both of those numbers in both basins. But nevertheless, in the North Pacific and the North Atlantic, each season, one could expect 80 to maybe even close to triple figures in terms of the number of hurricane force lows that move through those areas. That's not to mention all the gale force conditions, all the storm force conditions, which, and from a warning standpoint, can, in the North Pacific and the North Atlantic, reach upwards of 5 figures every season. So there is a lot of cause for us as forecasters to be super vigilant about the weather systems that are affecting the oceans for the safety of life at sea, to safeguard your cargo and the people aboard your vessels. I also wanted to show this image, and Chris and I both, we get emails from the National Geospatial Intelligence Agency, kind of talking about the hazards that might be out there on the ocean at any given time. And in a lot of cases, we get information about derelict vessels, sometimes space debris, occasionally cable laying, we'll see things like that. But in other cases, unfortunately, we see things like distress signals from vessels, people overboard, or unfortunately, maybe a vessel sinking and the individuals having to abandon the ship in dangerous situations. On this screen right here is just a compilation of 15 of those other types of events: the distress signals, the sinking vessels, the people overboard, just from November the 21st to December the 3rd. Now, not all of these may have been due to weather, but I bet some of them were. And like with the hurricane force lows that cause a great problem to vessels crossing the ocean, sometimes those crossings take, 14 to 21 days. These issues that occur, some of which likely occur with weather, are also something that we want people to avoid. And through our forecasts and warnings, hopefully critical decision makers can make better decisions on what to do to avoid the bad situations. This is another example of a really deepening low pressure center moving near the Northwest United States. This is back on October the 24th. And in the upper left, you see a zoomed out view from a satellite image of the comma shape with a big swirl in the middle of the low pressure system, and the comma shape of the entire broad low pressure system extending from the Northeast Pacific into Southwest Canada and the western part of the United States, and a zoomed in view on the image below. And Chris showed some images of vessel traffic, and this we also superimposed on this satellite image some vessel traffic, which you can see. Fortunately, in this case, most of the vessels were a little ways away from the really bad stuff, or the maximum winds likely around the center of this low. Some are pretty close, although on the edge. It might have been better to avoid that just a little bit more, but nevertheless, there was pretty good avoidance in this situation. And this is what a positive result of forecasters being there 24/7, 365, monitoring situations and getting the best products out for you and the people that you serve, is that we hope that through the decisions that you're able to make from the products that we provide for you, all the information that we provide for you, you're able to make good decisions to take that avoidance into consideration, to make sure you avoid things like, it's a little bit difficult to see in this thumbnail, but seas upwards of 45 feet or so near the center of this system. So what do we do? And Chris talked about a lot of the ways that you get information, how you get information, and where to find it. And the Ocean Prediction Center, it's very similar. Through our website, ocean.weather.gov, you can find examples of over 150 products that we issue each day. Some are automated, some are done by the forecasters, such as our analyses, which show the main frontal features, low pressure systems, and the boxes noting the hazards that may be associated with each of those low pressure systems, such as a gale, developing gale storm, developing storm, hurricane force, developing hurricane force, or freezing spray. And those can be all noted on those, along with the forecasts that go out from 24 hours to 96 hours Right now, our 24-hour surface map only covers a small segment of the North Pacific, and on the other side, the North Atlantic. We're working with our forecasters and with our developers to increase the scope of that product to include the same area that the 48, 72, and 96-hour forecast show. We have wind and wave forecasts associated with each of those time periods as well, along with 500 millibar charts and automated wave period and direction charts. 4 times a day, we do wind and wave analyses of a regional snapshot of the North Pacific and the North Atlantic. Once each day, we do a full basin sea state analysis of the North Pacific along with the North Atlantic. The Atlantic is done during the daylight time, Eastern Standard Time. The Pacific one, the sea state analysis, is done at night. We also do some of the similar forecasts and analyses for parts of the Arctic. And we include 24, 48, 72, and 96-hour forecasts for that, along with some sea surface temperature ice edge information and some experimental freezing spray information. I would like to note that very recently, within the last couple of years, the NOAA component of the U.S. National Ice Center has fallen under the Ocean Prediction Center. It's now part of the Ocean Prediction Center as the Ice Services branch, and you can see its website there, usicecenter.gov. And the Ice Center does a lot of analyses of high latitude ice, some iceberg situations. They'll also do a lot of decision support services for vessels that are traversing very vulnerable areas in the high latitudes. Other things that we do, Chris mentioned this, but we have our contributions to the National Digital Forecast Database. And currently in the Ocean Prediction Center, we do gridded data for about 250 miles or a little bit more offshore of each coast of the United States, the continental United States. You can see in this image, Alaska has its contribution to the National Digital Forecast Database around that state, and the contributions from Taffy and Honolulu also in the image to the left. It's our hope that at the Ocean Prediction Center, we'll eventually able to fill out the rest of the North Pacific and the North Atlantic with our gridded information as well, examples of which are shown on the right side of the screen with wind information from 15Z on the 6th of December, with the yellow winds just to the west of the state of Washington, indicative of gale force winds, and on the right, the higher seas, upwards of 12 feet or a little bit more, from 12 to 15 feet in the areas associated with that gale, on the significant wave height image just to the right of the winds. So how do we do what we do? Well, everything starts with an assessment of current conditions. And it's great when we have some access to buoy data. It's super great when we have access to ship data. But a lot of our information of the open ocean is taken from satellite data. And on this image on the left side, if you were in space 22,500 miles above the surface of the Earth and could breathe, back on January 24th, 2020, this is what it would look like over the North Pacific, south of Alaska, west of the US, and north of Hawaii, with a strong low pressure system over the North Pacific, with a frontal boundary extending to the southeast from there and going southwest to the northwest of Hawaii, well into the Central Pacific. Other low pressure systems, if I was able to put this in motion, would be over the Western Aleutians, just south of the Western Aleutians, over the Gulf of Alaska, and another low pressure system, at least one west of the Northwest United States and Southwest Canada. It's these images that help us ascertain, without many observations, where low pressure systems are, where the frontal boundaries are, and where they're moving towards and coming from. On the right side, we also see the data we get from satellites. In this case, we get altimeter data, or the satellite senses through its ability to look at the chaos of the seas, if you will, how high the waves are likely to be associated with that swath. And in this case, on the right side, it's an image from the Atlantic, actually, but in the center of a real strong low pressure system. This altimeter pass, which are done by polar orbiters, indicated 59-foot seas with a hurricane force system over the Atlantic at that time. Satellite imagery also is able to sense the approximate speed of the winds for the polar orbiters, And in this case, there's an image here with the brighter the colors, the hotter the colors representing the stronger the winds. Yellows would be basically gale force down to the light blues, which would maybe 5 to 15 knots. But then you get to the brown colors, which are storm force winds, and the reds, which are hurricane force winds. And this is an image taken from November of 2019 off the west coast of the United States, off the coast of Oregon, with a low pressure system just off the coast there, and a broad area of hurricane force winds on the west side of that low pressure system off that coast. And so again, this data helps us with an assessment of the current conditions, from which then we start to look at model guidance. And understanding what the current conditions are, we can kind of look at different sets of model guidance. We have our global forecast system, our North American model that we can look at, and others run by the National Weather Service. We have models that we look at from weather agencies around the world, from Japan, from Australia, from the United Kingdom, from the European Consortium. And we look at all these different data sets to try to figure out, okay, based on the current conditions, which one's doing the best? Which one do I trust going forward? Which has the best track record of late? And this image here is the GFS in yellow and the European Center for Medium Range Weather forecast in orange. And you can see in most cases they're showing pretty similar situations. Oops, I went, let me go back again. You can see low pressure over northwest of Alaska, a little bit different location, maybe off the west coast of the United States. Low pressure system is a little bit stronger forecast by the GFS as opposed to the European. You can see here just to the northwest of Hawaii, low pressure systems, maybe a little slightly different location. This is overall pretty favorable in terms of the consistency from one model guidance to another, but there are cases where they do differ a little bit more markedly. It's in those situations where the forecaster will look at current conditions, track record to make the best forecast for you. And all of those models are taken, really developed and run based on observations, not just from satellite, but I'll call them ground truth, and I put ground in quotes, because in this case, we're looking at observations over the open ocean. And I show an example here about the importance of observations. This is back in 2015, but it's a very, very good example where in the middle of the screen, there's a low pressure center with a front in the line that goes to the northeast and then to the south from the low. On the west side of that low, there's an observation here that may be a little bit difficult to see, but it's an observation of winds of 65 knots at that time, again, on July 29th, 2015. And so it's unfortunate that a vessel got caught in 65 knot winds, but it's great for us as meteorologists to know that exists, because that'll help us to validate our forecast or to improve upon the forecast that we already have in effect. And in this case, you can see why this observation is so important, because there's model data here, which this is from the GFS, taken from the same time period, July 29th, I think just before the observation, which shows actually the low pressure system as forecast by the model to the southwest of where the observation from the northwest winds were. And so what you can see in this case is what the model guidance had winds rotating counterclockwise around the low. The model actually had southeast winds with a low a little bit more to the south, as opposed to what reality was, low pressure a little bit more to the northeast and winds screaming from the northwest. And it was actually in this case that forecasters were able to update their forecast. I think it was from a storm warning to a hurricane force wind warning at that time. But it goes again to show the importance of the observations, because with this one observation, we got a warning out that was upgraded and able to, I think, help inform better other vessels that may have been in the vicinity. In this map here, this is taken from the ship observations team, the WMO IOC ship observations team that I do chair, and it shows really the sparsity of observations globally. The red shows and the pink show basically globally where there really aren't too many observations taken at all. When you get to the oranges and the yellows, maybe a little bit more, and then the blues and the greens where it's kind of okay. But even where you have the blue, that's 26 to 250 observations per month, which could mean in each one of those blue square grids, that could mean we only get one observation per grid square per month. So it's not too many, and any observation that you take is vital to our forecasts and warnings. And just wanted to note that the WMO has an observing system capability analysis and review tool called OSCAR that has requirements for different measurements for global numerical weather prediction. The goal of observations, just for air pressure, is an observation taken every 15 kilometers every 60 minutes. But even if we get observations, an observation every 100 kilometers taken every 6 hours, that would result in a significant improvement for air pressure. And you think about the same things with temperature and wind and other things, it would make a significant improvement as well. And this is an example of the scatterometer data taken from the polar orbiters in the swath. And even though satellite data does help us to see a little bit, quite a bit in the open ocean, there are still gaps in those polar orbiters. And these polar orbiters only go across the oceans every so often, I think about every 6 hours or so maybe. So there are periods where we don't have anything, or there are gaps there where hopefully vessel observations and buoy observations can make a difference. I have a couple more slides and then we'll turn it over to time for questions. I want to note that, like Chris was mentioning, decision support services at the Ocean Prediction Center, we have begun providing decision support services, doing it now for the last couple of years or so for the U.S. Coast Guard off of the east coast of the U.S. And we plan to expand that hopefully in early 2022 off of parts of the West Coast. We do this once a week on Wednesdays, updated more frequently as significant conditions warrant. And in those, we try to give to the mariner, quick indicators of the hazards over the next 7 days and periods of which one may want to consider avoidance plans to avoid like the really significant weather. We've also done support services for some unfortunate conditions where a vessel has been caught in a bad weather situation and folks have had to abandon ship and the Coast Guard has to try to do a rescue or sometimes unfortunately recovery situations. But we want to make sure that the people that are involved in those situations are safe, but also the Coast Guard personnel who may have to travel a long ways with very precarious fuel supplies are also safe in trying to time out their rescue missions and do that in a safe way. We've also had more, kind of positive decision support services with efforts to do things like clean up oil from World War II sunken vessels that have been off the coast for a long time. And now there's an opportunity with some resources to be able to go down there, extract the oil, plug the holes, and try to limit, for example, oil sheens or oil globules getting onto beach lines and coastlines. So we're able to do things like that as well. It is our strong desire that the information that we provide through the National Digital Forecast Database and in other ways get into things like EXDIS displays, and electronic charting is definitely moving forward, incorporating all sorts of data from a vessel into that system. And we also want weather to be a part of that. And we believe that the information that we put into our National Digital Forecast Database can be a real nice contribution, real nice part of what ECDIS can be. Future of high seas forecasts. Right now we do a lot of high seas forecasts, especially in the North Atlantic and the North Pacific, that are very long, well over sometimes 10,000 characters. Very difficult to read, difficult to understand, but something that's been going on for a long time. And all of us right now are working on kind of polygon way to do high seas forecasts, which could translate into a simpler way, a way with more brevity, if you will, of getting high seas information out to individuals, maybe similarly to what I showed with the NGA signals and information earlier on in the presentation. We do need to, though, serve mariners with 21st century information. Right now over the North Pacific and the North Atlantic and in all our high seas forecasts, we tend to attribute gale conditions and other hazards with low pressure centers. And in some cases, either resolved by satellite or resolved by the models or both, there can be multiple low pressure systems in one major area of a hazardous wind. In this case here, I just show 3 in a swath of hazards that goes from just south of the Gulf of Alaska, northwest through the Aleutians to near Far Eastern Asia, I think toward Kamchatka and Southeast Russia. But in this case, with a polygon, I could very easily basically just draw two slots, an area in, encompassing the yellow and some of the browns with the gale and the storm force winds to the southwest of that train of lows, and then another one to the northwest over the Bering Sea, which would probably, I think, be a much easier representation of the hazards for the mariners to be able to make decisions from. With the Ice Services Branch, the NOAA component of the U.S. National Ice Center, as part of the Ocean Prediction Center, we will be providing more combined forecasting and decision support at high latitudes as time goes on, and we look forward to being able to do that as these shipping lanes and sea lanes open up, because of just the ability with ice typically maybe not being there quite so often in the year. There may be more opportunities for decision support at high latitudes, which is really important because in those areas there aren't a lot of services. So if something bad happens, it may take a long time to get help. We want to make sure, again, the best information is available for those that go that way. Our social media presence, the Facebook link is there on the upper left. Our Twitter handle is located on the lower left or in the middle of that screen. And here's just an example of a storyboard that you can find occasionally posted to social media, showing the seasonal hurricane force low and all the information from those lows on a storyboard done by one of our forecasters, senior forecaster Jim Kelly. And with that, there's my contact information on the lower left. If following this presentation you wanted to ask me some questions directly, there's my email there. And so with that, I will stop sharing my screen and turn it over to Andrew to facilitate any questions.
All right, thank you very much, Darin. Yeah, we have so far 4 questions. A couple of them, I think just one for Darin and a couple for Chris. So there were 2 questions about the Sea of Cortez or the Gulf of California. One person asked, Steve asked, does the new tool predict corom? I'm not sure, that word is COROMUEL, coromuel winds in the Sea of Cortez. And let me just ask the other question about the Sea of Cortez before Chris answers. Sailors in the Sea of Cortez talk about localized squall events that move in rapidly called chubascos. Do any of the forecasting products provide predictions for these, or are they too obscure to predict?
Right, so the former term I'm not familiar with. However, we do often see prefrontal squall lines that especially as the waters are still warm, but we get some vigorous frontal boundaries passing through there. So we do include information about thunderstorms, with especially within our offshore zone forecast. And so it's that is available. We are considering in the future of having short fused products that might be able to better inform mariners over the next couple of hours. But at this point, it's a little more broad brush of whether or not thunderstorms will occur and roughly what's the coverage and the intensity.
Thank you, Chris. There are 2 more questions. For Darin, how are OPC forecasts coordinated with NWS, with the NWS forecasts for the same area?
Yeah, that's a good question. And so each area tends to have its own area of responsibility. Each office tends to have its area of responsibility, but they have seams associated with those bordering areas where we try to really coordinate the forecast to make sure that the forecast is consistent from one area to the other. So we have chat software to help us do that. We can pick up the phone. There are though occasions where we can do what I'll call passive collaboration. By that I mean I can see in my gridded data what another adjoining forecast office is doing in its gridded area. And sometimes I might not have to pick up the phone or chat. I can just make a little change to my grid just to make it match a little bit better, particularly if the change isn't anything really terribly significant. Yeah, I do want to mention that all of the centers, and it's the centers, the Ocean Prediction Center, the NHC TAFB, the Weather Prediction Center and WFO Honolulu collaborate extensively on surface analyses. And so every 6 hours, all 4 of the centers collaborate on a surface analysis that encompasses the continental United States and goes out over the open ocean, which is made into then a unified surface analysis. And then every 3 hours, I believe it's WPC, the Weather Prediction Center, and TAFB that coordinate particularly on a surface analysis that encompasses the continental United States and areas very close to that, including Canada. So there's a lot of collaboration that goes on, and sometimes there's not enough time to collaborate to get that we'd like to get the forecast out. But knowing the significant weather situations, we're collaborating pretty closely to make sure that there aren't multiple stoplights at the intersection, that the hazards are certainly in a consistent way, that you can make the best decisions as you go from one forecast area to another.
Thank you, Darin. One person is asking, I'm not sure which one of you wants to answer this question. What is the difference between grid files and GRIB files? Like grid with a D and GRIB with a B.
Chris, I'll let you take that. I don't think there's too much difference, but you probably have a little more technical wherewithal than me, so go ahead.
Actually, no. I'll punt to your knowledge there, Darin. Thank you.
Oh, goodness sakes.
No, go ahead.
I was going to say, I think that the GRIB files are those files from which the grids are made into. So we talk about them interchangeably, but the grids are what the forecasters use in their vernacular to come up with the information in our graphical or gridded forecast editor. And then into the NDFD, the output that you're able to see, I think, comes out in GRIB format. So I think I have that right. If you want to find out for sure, just go to digital.weather.gov. Again, that's digital.weather.gov, or do a search on National Digital Forecast Database, or NWS NDFD, and you'll find out everything you need to know when it comes to our gridded database and the GRIB files from which I think the information in our grids goes.
Thanks. There's one last question that popped in. It was just a little bit about geography, about the Arctic and Antarctic. Chris mentioned only the Arctic for future forecast effort. Darin showed a picture of the Antarctic. Does the NWC provide any products covering the Antarctic?
So the U.S. National Ice Center does produce some information for the Antarctic. I'm almost certain of that. Actually, the Ocean Prediction Center, we do this on just a more of an internally coordinated basis for researchers going to the Antarctic this time of year, which is, I guess, in the southern hemisphere, the warmer time of year, colder up here, obviously. But we do some internal products in support of some, I think, NOAA research vessels going down to the Antarctic. So yeah, the U.S. National Ice Center does some things down there. I can really see us as a national weather service, and particularly as centers combined, gradually doing more and more services into higher latitudes, because those areas are just going to be served more as the ice is more vacant during the season. Takes a little bit longer in most seasons to come back, although this season is an exception. And to support more vessel traffic that may be going up there, more vulnerable vessel traffic, sometimes maybe exploration of resources that the U.S. government tries to take on and so forth. So I see us gradually broadening our scope there and providing more decision support services.
All right, well, thank you. Well, that's all the questions I have. If anyone thinks of any more questions, though, of course, we're going to be sharing these presentations and to your email, and the email contact for both Chris and Darin is in those presentations. Ooh, just got a couple more questions here, but oh, they just said thank you. Okay, but if you do have any additional questions, you can email Chris and Darin, and the recordings will be available again. So thank you, everyone, for attending. I'll go ahead and stop the recording, and we hope you all have a great day.